So I'm going to start just to calibrate and see where people are in this, because essentially this is, um, I'll joke, when I was in graduate school, my advisor said, the sure way to get a paper published is to take two sexy topics and put them together in the same title. And it works in terms of interest, uh, but I think the real intersection with this is what we're going to be talking about. So how many folks think you know what a data fabric is? Few. How many are actually doing something they would consider a data fabric? One, two, okay. How many folks know what generative AI is? More. And how many are actually doing something with generative AI now? Okay. So I think that helps me a lot. And if you weren't looking at the hands, there's more people that are working on generative AI than data fabrics, and a handful on each side that are actually implementing. We're early on both of these concepts, and in particular for data fabrics, this is a pretty abstract concept that's been touted by analysts now for almost 5 years. And there's industry analysts are always looking to portray the future and be early on. InterSystems started really marketing to this because a data fabric, which is typically the idea that you have data from multiple systems under common governance, basically describes many things InterSystems has done for a long time. So the data fabric journey for InterSystems started with a, hey, that's a new term for what we already do. Let's use it and confuse the innocent with a new name. It's grown to be more than that, both as more and more people are starting to adopt this instead of, I have a data warehouse, then a data lake, then a data lake house, and I'm going to just replace the same concept with the newest generation of that same concept. The idea that you don't have to replace everything is becoming more popular. And the idea of this data fabric, I'm going to use, I think, a fair amount of Gartner analyst slides because I think they do a good job. But last year in this conference, I went through the various analysts' perspective to demonstrate that they were all slightly different definitions. Right? This is still a concept and a conceptual architecture that people implement all around better data management. And typically it's about common governance across distributed data. But this kind of picture says, I'm spanning data that's spread out all over the place, putting it under an umbrella, and I'm tapping that data somehow to do analytics or decision support, or many of these are typical applications you've done already, but done in a different way because you can bring in additional data in a more automatic way, in a more nimble way. And is anyone here from Healthix? How about another health information exchange? Which one? VA, right? So the pattern of a data fabric fits an HAE extremely well. In fact, you probably hear our marketing group talking about data fabrics, like HIEs as data fabrics, because the data can be spread out. You can have an edge gateway as well as a centralized version. You use the same data for many applications, and you're trying to govern it in a common fashion. Healthix, who is here, you run into them and want to talk to them, has found a lot of success in a health share implementation that is just very high scale and pretty mature in the kind of applications they've done with it. So the scale you can read, 9 million alerts a month is pretty large. 300 million data elements in a common uh, centralized view fits a data fabric pattern very well. So if you're used to InterSystems and health share, you can think of data fabrics as being approximately that. You've got data that's maybe spread out all over the place that you want to bring together into a common form and use for multiple purposes. We are using essentially a picture that says that you have data in multiple places going to different consumers. When I go and talk to customers, or even people in the industry, often they call this quote unquote the data problem, right? It's so pervasive. But data is sort of intrinsically siloed in many organizations because the operational systems are the producers of the data. And all of the downstream applications, especially analytics, are essentially derivative from that data, but they want to connect data between multiple silos. There's plenty of seats if you want to come in instead of having to stand the whole time. And the basic principle of you can connect to the data or collect to the data is one of the emerging key things about data fabrics. In health share, you can think of this as a gate, edge gateway kind of thing. But in general, these are the areas that we're building more features in Iris towards, things like foreign tables or federated tables, so that you don't need to ingest the data to explore it or to use it. And in the industry, that's sometimes called data virtualization. The challenge with all virtualized data is what I'd call the law of physics, that often with systems, especially key mission critical systems, once you know you want to use that data, you want to cache it. For example, in our supply chain practice, every single customer has one or more SAP core systems. SAP, despite being such a mission critical system, is actually fairly fragile. You don't want to be hitting SAP with every query for every analytic instance. You don't want to be dragging large amounts of volume out of SAP on demand because you'll bring it to its knees. So there are reasons to collect the data as well as to connect to the data. And therefore, again, features like foreign tables are meant so you can start with the data remote, explore it, see if you really want it, and then turn on ingestion without changing your queries. The idea of there being consistent data and metadata in health share terms, and I must admit that I've been an Iris guy. I'm still learning health share more. So I see the faces in the audience that you come up to me later and educate me if I am not quite getting it right. But the idea of a data catalog is essential to these data fabrics, that you know what data you have and you know where it is. And HealthShare has that. For example, the sysindex is effectively a data catalog for the data in HealthShare. The Data Fabric Studio, which we talked about this morning, explicitly has a data catalog. And we also have partnerships with people like Elation and Calibra that do nothing but data catalogs. But the essential thing is that metadata is data, and often that metadata is important for applications. And then the third one is this idea of being able to do real time. And that's something where, compared to others that are doing data fabrics, I have on my shelf in my office all of the books about data fabric ever written, ever published. And there's 9 of them. They don't all agree. And only one of them really considers the benefit of putting analytics into sort of inside the fabric. what is common to all of them is that there's lots of moving pieces. To really pull this off well is still complex, and you need the ability to connect to, ingest, normalize, deduplicate. Sometimes you want to use the unstructured data. So this is a fairly complicated picture, and you want to do that all with common security, et cetera. So if you look at the analysts' publications, they all have this various thing, and they will tell you that nobody on the industry has all of the pieces, but that InterSystems has many more of the pieces than anyone else. In the Data Fabric Studio, we include this thing called the semantic layer. This is also available separately as part of what we call adaptive analytics. And again, the idea is that you have a single data model across multiple systems. This is a drag and drop thing called the canvas. One of the few things that InterSystems doesn't organically build. We've partnered with a company called AtScale and built integrations around it so that you've got a nice model and you can connect to data from multiple sources. And often different applications want different views of that data. If you have business analysts that are living in Tableau or Power BI, they're often confused by the names of the tables that are there from operational systems. So a simple thing as renaming it to a friendly name and subsetting it down to things for that application can go a long way. And then another example in financial services that makes heavy use of this real-time analytics is a company in New York called Broadridge. If this Broadridge spun out of ADP, which is a name you've probably heard, in the late 80s, they have thousands of operational systems that are financial, so it's quite complex. And they use these real-time analytics, and by analytics, they mean things which you would consider, moving averages is an analytic, or trading derivatives. Think of calculus, first, second derivatives of the change rate. It's been an extremely useful project for them. They're on their third application. And one of the things they taught us as InterSystems is that they had been already built a data fabric pattern with AWS components. And then they did the same thing with InterSystems Iris, and they found it was under a third of the size of footprint and 9 times faster. If you're used to Iris, I think that's not too much of a shocking message. It's simply because it's all pre-integrated, and we make fewer copies of the data, and you don't separately scale out 5 different pieces. You have really one platform. But they gave us this picture that says, here's all the different pieces if you assembled this from things in AWS versus using Iris. So that's really the data fabric story. Most of the financial services customers we have are well down this road. Data fabrics in healthcare on the Gartner Hype chart are still moving up, but is anyone here from MetaClinic? Or anybody here from Utah? Okay, maybe you want to talk about why you like the data fabric and what you're doing with your project. If you don't, I'll talk about it.
Yeah, I'm talking about it next hour.
So stay and go to the next hour, but Reed, why don't you give a 2 or 3 sentence overview for people?
Yeah, so at our institution, we've had the vision put forth by our CTO right here back in the day of having a data warehouse, one-stop shop for all of our data and to enable analytics and all kinds of other stuff. And it is that vision came about before data warehousing, really. So we've had it for a long time, and it's been harder and harder to maintain that. And so our search for a a fabric that would be a one-stop shop for everything is kind of where we came about to um, wanting to use the smart data fabric.
So hopefully this gives you, if you haven't heard of a data fabric before, a sense. I'm happy to, we have stuff all over our website. I'm happy to answer questions to demystify things that are written in marketing speak into real world stuff. You have a question?
Yeah, what the term data mesh also used synonymous with data fabric, and sometimes can you explain the difference?
Yeah, so I can also send, I spoke at the Data Summit, which is an industry conference about this. Data mesh and data fabric are basically siblings, and that has also changed in terms of usage from different analysts. Today, the general consensus is that data fabrics tend to be an infrastructure on which you can govern them as a data mesh, which is distributed governance, or as a data fabric, which is common governance. What's typically associated with the data mesh is the idea that instead of a single organizational group doing all of the governance for all the data in the organization, you distribute it. And by distributing it, you give ownership to each group, and that group then publishes a data product. It's more hypey than data fabrics today. I have met exactly 2 companies that have pulled off a data mesh in production, one being Capital One, where you're really selling data on a broad basis. That's a really good application for a data mesh. You can tell I'm slightly biased against data meshes, but the other company they met that's done a nice data mesh is the New York Times. So both of these are very sophisticated organizations with really good staff that have a incentive for monetizing their data, and they literally have a product manager for each data product, and they treat, for example, Capital One has 12 data products, 12 data managers. They have quality managers for each data product, and then they have a couple hundred internal data sets. So if you are in the regime that you're monetizing data and you want to treat it as a product, then data mesh is a good idea. I think I could spend a long time on this, so we could talk later. I think from an InterSystems perspective, first of all, this is still relatively early in terms of our customer base. Most of the healthcare research patterns are using this data fabric idea. They're sort of coming into either a centralized CDR that they share from with a traditional sort of data lake zone thing where you have a zone where you're de-identifying data and then you share it, and that's very heavyweight, or they're using this kind of governance data fabric. I think trying to do data products for research use, the business model doesn't work. Okay, so I digress. Any more questions generally about data fabrics? I'm now going to shift gears and talk about, if you will, in the chocolate and peanut butter. I'm now going to talk about peanut butter, and then I'm going to talk about how the sandwich, peanut butter and jelly, I guess, the jelly and peanut butter fit together. Yes.
You had mentioned caching earlier.
Yes.
I know you're probably using this as a metaphor.
Yeah.
Is this really, really memory intensive if you want to implement this?
Yes. I mean, of course, it all depends. If you want to use large data sets remotely, you're going to hold them in memory someplace. If you want to join between 2 different large data sets that are in different systems, you got to fetch them to join them and hold them. It is memory intensive. And then, of course, there are various techniques for how do you optimize that. Okay, so short history. Who has not seen this paper before? So if you remember Terry yesterday talking about AI is all based in neural nets that came from the 60s, there have been periodic AI winters and thaws that are around one breakthrough or another. Machine vision had a big breakthrough in the mid 2000s, but the breakthrough for generative AI is generally dated 7 years back to this paper from Google about a thing called transformers. And the essential key to transformers is that rather than having these neural nets always having feedback loops that you have to, everything depends on everything else, it's a technique for unfolding it and running it in parallel so that you can now have neural nets that are much bigger. And that has led to neural nets that are way bigger than ever could exist before, because now you can compute them. It's not sheer memory and CPU, it's an algorithm breakthrough. And at some level, these things have, some people call this emergent behavior, right? That like, let's make these big and see what happens. Oh, they start feeling almost human. For reasons that certainly I can't fully explain, but it's often called emergent behavior, which is, I think, code for nobody understands it. The curve here has continued to go up. You know, GPT-5 is probably an order of magnitude above that. Same thing with the Google family and the Amazon family of algorithms. And that's why they're so expensive, and only the very largest cloud companies can do this. Apple yesterday announced that they were putting their own models in with Siri. They're considered now to be medium language models. So you start seeing these t-shirt sizes of large language models, medium language models, small language models, and an emergence of things that you can run securely in your server for surgical purposes. And I think there's a lot of benefits. I won't belabor this. I think you heard this from people yesterday in healthcare. If you saw Merv Adrian's talk this morning, there's a, keep calm, but start getting into this. So for example, InterSystems has now spread the number of people that know this technology. We're trying to upskill. We're having to create our own training for this, but it's something you really can't ignore. Our strategy is not to build foundation models, because that is Google and OpenAI and Apple are in that game and we won't keep up. But instead to learn the 3 basic techniques: to learn how to do good prompt engineering, to learn these retrieval augmented generation patterns, which you can go a very long way with those, and to learn how to tune models and maintain models. Where we're tuning models, we'll use an open source model, because that's the emergence of sort of, it's, instead of something opaque from OpenAI, you can go to Hugging Face and get a model that you can tune and version. I know this is a whirlwind about GenAI. Any high-level observations, or someone who wants to offer experience? There's 4 different sessions here about use of vector search with LLMs. And if you want to get deeper, I'd recommend them. So the patterns that at least I'm seeing at a high level are about the combination of this GenAI and data fabric are a couple of things. The first is that as folks work to become quote unquote GenAI ready, and Merv Adrian essentially says the same thing in different terms. There's an aspect of being ready from a security aspect, which is not substantially different than good general data security and privacy practices. Just have to be extra careful because when you use these models, you don't know what they've been trained on. AI-ready principles, and that's governance, ethics principles, et cetera. For InterSystems, we have now a whole code of these things and things that every project has to go through. And then AI-ready data. And this is a survey from now 9 months old, from October, of about 900 firms about where they thought they were ready or not. And it turned out that data was the area that these organizations were least ready on. That only 4% of organizations felt like their data was AI ready. And then about 22% of them actually felt like they knew what AI ready data meant and that they had a program towards it. And about 40% were like, I don't really know what ready means, but I know I'm not. So there's a, if you look on our learning services, new learning paths for GenAI, have a session about this. What does AI ready data mean? What are the principles? Half of it is more governance than technology. And then some pieces are technology oriented. So you can use these data fabrics to make your data more GenAI ready. And it's actually quite simple in principles. You don't need to use a data fabric for this. One is having access to the data you need for RAG or tuning. The second is to put that in the right form. And the third is really all about control. That it's not as much a matter of data quality as data control and auditability. A little bit different for machine learning and GenAI, because one is considered to be more susceptible to data quality issues. But the key principle is know what you're feeding to these models, which means having a data catalog, knowing what data you have, knowing what data you're feeding to it, having auditability on that data, having those data sets so you can trace what was used and what wasn't used. And as there's still relatively few customers that we have that are fully into production as opposed to pilot and have really these experience things, but their feedback is that the game sort of changes after you're fully into production, where you're debugging things. It's not, can I make a system that is useful? It's when things inevitably go wrong, how do you know what went wrong? What's the data in the model that you tuned? Was it the data in what you were feeding to the model through a RAG pattern? Was it your business logic? So this is not so different than any other application where you want to be able to debug and trace, except that these models are not deterministic. You can give them the same input twice and get a different output. So it drives your QA people insane and makes the need for auditing and these frameworks especially important. So that's one key pattern. I think we're working with a couple of HIEs in this area because it's a big thing to apply, for example, broad population data to machine learning models, either for predictive or explanatory purposes. And it's healthcare. So, one example is the NHS has now centralized all data for the, country of Wales, and it's a gold mine. But as they use that data for different purposes, that's what they're telling us is that the key for them is control of the data. There's a couple other elements that'll go in, and here I'm getting probably for the show of hands that I saw, just this might seem esoteric. Just think of it as something that's going to be in the future. This radar chart is a Gartner thing that is about for Gen AI, what are the key technologies and techniques? And the way you read it is, from the inside out, when is this whatever technology going to be most in use and most, essential? A year ago, people thought RAG, retrieval augmented generation, was a cool technique, but it was sort of advanced. Now, almost no one uses an LLM without RAG. And then the size of these quote unquote mass is like what's for them the vendor mass. How many different vendors will be available to provide this kind of thing? And I'll focus in on three of them: virtual assistants, code generation, and GenAI applications, just to give you examples of possibilities. In our rubric, remember this architecture is not real technology you can put your hands on. It's architecture drawing pretty boxes for conceptual purposes. One pattern we talked about is feeding GenAI from a data fabric or from something perhaps less sophisticated, that either way, that has good governance, so you know what data you are feeding the LLM. The other one is putting GenAI inside, and Scott talked about this a bit on stage. One aspect is that the UI for your data can be natural language. So there's a few good models now, and this is emerging all the time, getting better and better. Code Llama is pretty good at taking natural language to SQL. The way that InterSystems is doing this is to essentially take the best model for SQL generation, adding to it the prompts that are about, here's how you use SQL in Iris well, and then adding to that the information about your data model. Here's the tables, et cetera, and that the data model information comes directly from the data catalog. So this is on what we're now calling our Data Fabric Studio, where it's financial data for people's accounts, and you're just basically saying what is the value of the positions, and that is translated to a SQL query that's looking for the value and giving you some. So it's conceptually simple. You're translating human language to SQL. It's actually quite tricky. I don't think this is not yet a standard fully supported component from InterSystems because it's squirrely. You change the prompt a little bit, you get a really different interpretation of what the result is. So we're actively trying to work to make this more predictable for a developer. But for example, the demo that you saw on main stage with Alvin today uses the same technique. Same technique is being used in our supply chain, our financial services stuff. And the basic idea is that not necessarily developers or data engineers, but normal humans will choose this as their preferred way of interacting with data. The second pattern is to build applications, full applications, and you saw a lot of that from Don Woodlock's team's, to me, incredible demos. And from the use of InterSystems technology as a developer standpoint, you have an application, and GenAI is just another technique to fit into your application. Now it's the same data. Perhaps you're using it in vector form for with an LLM to provide a different UI, but for most of the current customers of Iris that are extending their applications this way, it's an extension, it's not a net new application. You know, the example from TrackCare today, TrackCare, it's doing the same fundamental function of helping a clinician keep track of the patient notes and use that in different ways, but it's now adding, you know, a really revolutionary new technique. It's still not changing the value prop it's not a completely different animal. It's just, instead of a house cat, it's a cheetah. And then the third pattern is the code generation pattern. I showed you the DTL generator, I showed you a Python generator earlier. Alex McLeod on stage showed a coding example that was really generating HTML as a code. So they're things that you don't really think of as code, but they are. And we're looking at doing the same kind of thing with BPL, et cetera. How many folks have their own language inside of their product? Nobody in the audience? We have a bunch of customers that have invented a language, a meta language for application generation on top of Iris to do cool stuff. That is very amenable to, as long as there's a human in a loop, to doing this. And for a lot of the data fabric elements, this is where we're going. Data transformations are part of a data fabric pattern. The more we can automate it, the easier it is. Data discovery, where you're going and looking and quote unquote inferring the schema at a source system. The workflow, the data quality assessment using generative AI is a very hot field right now. So almost all of the complicated boxes that I drew inside of our data fabric architecture are areas where there are possibilities. I'm not saying no promises, but possibilities for dramatically improving the efficiency and effectiveness of the data fabric. The next thing out, just as a couple other techniques, Alvin talked about multi-model, also on stage. And I mentioned the challenge of LLMs being trained on a lot of data. Who has not feel like they're familiar with RAG and how it works? Who has heard this story so many times they don't want to go through it again? All right, you win. I'm happy to go through this. Lots of good material. There's material on our website about this, but it's important to know, if you're going to get into GenAI, learn prompt engineering, learn how RAG works. You may never need to tune a model, but those two are within the reach of any organization, even if you're not a developer, and those are areas to get skilled up on. And then there's another technique. There's a session here, as well as a tech exchange example, which is about orchestrating different models. And it seems fairly exotic, but in traditional predictive machine learning, what happened is there's a whole family of different algorithms for doing predictive modeling, and then it no longer became obvious which one to use on which problem. And the data scientists, when they finished their 90% of their time data wrangling, that was what they did. Like, well, this looks like a random forest would do better. And then a whole class of auto ML came out that just threw compute at it. I'm going to take this problem, I'm going to run 10 different models at the same time, see which model gives the best results, and pick that one. What emerged, that's called ensemble learning. And what emerged from that is that typically the winner was a combination of multiple models. It was rarely a single one. And we had a session last year explaining sort of what the intuition behind ensemble learning. The same thing is just beginning to happen with generative AI, that you have one language model that's used for the purpose of understanding the query, and another one that double checks the output for domain relevance. So for example, if I'm going up to a GenAI based system, the second thing I'd like, does it give me an answer? Then I ask it, how can I build a bomb? And if it tries to answer the question, then I know it's not production ready, because it should recognize that that's not its domain. It's an inappropriate question, and say, I'm sorry, I can't answer that question. That's a really easy thing to do. And if someone has not done that, this is not a production ready thing. Or what's another example? Not one of our customers, but a major airline put out a system for generative AI that was to explain and help passengers that got stranded or flight delays, and like, what flight can I get on, etc. And then people would naturally ask, well, how much is the difference in fare? And they had a bunch of customers that got a fare quote from this machine that then went to the booking agent at the gate, and they're like, no, this is not $200, it's $800. And they lost in court, right? What the machine tells you is, so they lost 10-ish million dollars because they hadn't told their GenAI system to not give out a price. So it's fairly typical now to have one kind of model which is watching the other kind of model. The head of our data security group loves this pattern for security purposes. So the visual trace and the plain old interoperability that's been in InterSystems Iris for quite some time, dates back to Ensemble days, is actually a pretty good practical technique for this. Not only can you stitch together different services, but you can also tell what's going where. So this is an example where the request from the front end into the vector database is one of these messages. The next message is going into the database, into the vector database and back out. And what you get, you can see what came out. And then the next thing is, okay, what is the message that goes back out to the chat agent? So I'm not saying that this is the only game in town. There's a variety of what are called chain operations frameworks. Llama Index is an example of it. But if you know and like Iris interoperability, you can use this today to go back and forth between different things. You can put an LLM system in parallel with production and not use it at all, but you're tracing what it would have answered. And it's a really important kind of technique for getting some confidence pre-production and getting some auditability post-production. Okay, so as a very high-level view, I covered these two hypey subjects, data fabrics and GenAI. I like the pattern of using a data fabric to control your data so that you're ready for your data is quote unquote GenAI ready. But if you don't already have a data fabric, I'd say just start simple, right? Just make sure that your data is under control. The combination of these with vector and RAG can make much better application. And then where we're going is to apply generative AI inside the data fabric to make these data operations easier, more automated, and more effective. I think that big, large-scale data integration and data fabrics will always be complex. Systems of systems will always be complex. So I'm not saying that my sister could do this. I'm saying that we can make it much easier over time and much more effective over time. Any questions or comments? If you want to know more, there's a lot of information behind that. A lot of it is still, when it comes to data fabrics, still sort of at the architectural pattern level. So we're still working on getting practices for how I want a data fabric, and this is what it means in terms of how do I set up different systems together, and how I work with my data catalog. If you're interested in that, come talk to me. Thank you very much.